Now let's just move on further and talk about our new topic or the new concept, which is nothing but the division algorithms for the polynomials. So what is division algorithm for the polynomials? This says about how we can divide a particular polynomial with another polynomial, because if we have a cubic polynomial and we have to find the number of zeros of this polynomial if we have given only one polynomial, then for this case we have to use the division algorithm for the polynomial. So let us suppose we are talking about, or we consider any particular example that how we can divide two polynomials. So let us suppose consider we have x plus 2 a linear polynomial and 2x square plus 3x plus 1 as nothing but a quadratic polynomial. So let's just divide these two polynomials. I hope you remember how we can divide these two polynomials, because we have already done this concept, or we already have done dividing the two polynomials in the class 9th. So let's just start with it. First of all, the very first step in order to divide the two polynomials is we have to arrange all the polynomials in the decreasing or the descending order of the highest degree or of their highest degree. It means, let us suppose we are talking about x plus 2. We do know that x2 have the highest degree as 1 and 2 has a variable with x having a degree as nothing but 0. So we have arranged both of these polynomials in the descending order of the highest degree of the polynomial. So let's just divide it. How we can divide it? So first of all, we have to take the very first element or the very first term of the polynomial or the dividend 2x square. So we have to divide 2x square with the term x. So when we will divide 2x square with the term x, so let us suppose we are taking the very first step as we are dividing 2x square with x. So x and x got cancelled with each other and we will get the answer as nothing but 2 of x. So it means that we have to take the first term of the quotient as nothing but 2 of x. So it means the term, or let us suppose we say the quotient, the very first term of the quotient is nothing but 2 of x. Now we have to multiply 2 of x with the divisor whole. So let us suppose we are multiplying 2x with x plus 2. So we will get the terms as nothing but 2x into x is nothing but 2 of x square. Further, 2x plus of 2 is nothing but 4 of x. So we can write it as plus of 4 of x. Now as we are subtracting both of these terms, so the signs will get changed. So let us suppose we are talking about changing the signs. So if we are subtracting both of these, so if it is plus, then the new sign will be minus. So it will be minus, and further we know that over here the sign is nothing but positive. So after changing the signs, as plus minus is minus, so the new sign for the 4x is nothing but negative of 4 of x. So it means 2x and 2x got cancelled with each other. So both of these will get cancelled with each other. We will get the remainder over here as nothing but 0. But over here we have minus of 4x plus of 3x. It means we will get the answer as minus of x, or the remainder as nothing but minus of x. And we are left out with plus 1 constant. So let us suppose I am taking this plus 1 over here. So this is minus x plus of 1. This is minus x plus of 1. Further, we can divide both of these terms again, because x plus 2 is definitely our new divisor and minus x plus 1 is nothing but our new dividend. So let's just divide them again, and we can repeat this process until or unless the remainder is equal to 0, or the degree of the remainder should be mandatory less than the degree of the divisor. So let's just continue the process, because we do know that the degree of the remainder over here is nothing but 1 and the divisor is also 1. So we can divide both of these again. So let's just start dividing again. So we have the first term as nothing but minus of x for the dividend, for the new dividend, and we have the divisor as nothing but x. So when we will divide minus of x and x, we will get the answer as nothing but minus of 1. So it means that we have the second term of the quotient as nothing but minus of 1. So when we will multiply minus of 1 with the whole divisor again, we will get the answer as nothing but minus of x is nothing but minus of x, minus of 1 plus of 2 is nothing but minus of 2. Now let's just change the signs of both of these terms because we are subtracting. As we are subtracting, we have to change the signs. So the new sign for minus of x is nothing but plus of x, and further we have plus of 2. Now minus x got cancelled with each other. We got plus 1 plus 2, answer is nothing but 3. And hence at the end we have the remainder as nothing but 3. Obviously, the degree of the remainder is nothing but less than the degree of the divisor, because we can write 3 as nothing but 3 into x raised to the power 0. Obviously, the degree of the variable over here is nothing but 0, and this is less than that of the divisor. Now we can represent all this division into a new form. That is, we can write that 2x square plus of 3 of x plus of 1 can be written as divisor, into quotient, that is 2x minus 1 plus of remainder. So what is remainder over here? Remainder is nothing but 3. This is 3. So hence 2x square plus 3x plus 1 can be represented into the formation of x plus 2, 2x minus 1 plus of 3. So using this division process, we can able to find out the factors of any particular polynomial, and moreover we can represent any polynomial in such a formation, which is dividend is equal to divisor into quotient plus remainder. So let's just talk about the division algorithm more in brief. Now let's just further talk about the division algorithm. Let us suppose we are talking about any two polynomials, px and gx be the two polynomials with the condition that the gx polynomial can never be is equal to 0. Then any polynomial qx and rx should occur such that p of x can be represented as g of x into q of x plus of r of x, or we can say that p of x exists over here as nothing but the dividend. So dividend is nothing but is equal to divisor into quotient plus of remainder, where the condition on the remainder is whether the remainder should be is equal to 0 or the degree of the remainder should always be less than the degree of the divisor. So this is all about the division algorithm for the polynomial. This is called as, or this is known as the division algorithm, which says that for any polynomial px and gx there must exist other two polynomials q of x and r of x such that p of x can be represented as g of x plus q of x plus of r of x. Always remember the condition on the remainder that either it should be is equal to 0 or the degree of the remainder should always be less than the degree of the divisor. Now let's just move on further and let's just talk about some of the problems. So the problem number 1 says divide a given polynomial with another polynomial and verify the division algorithm. It says verify the division algorithm. So let's just start dividing both of these polynomials. So first of all, we have to arrange them. So let us suppose we are starting with the solution. So we have to arrange them in the descending order of their degrees. So let us suppose we are arranging them. So the step number 1 is we are arranging them in the descending order. In the descending order of their degrees. We are arranging them in the descending order of their degree. So let us suppose we are talking about the very first polynomial. Let's just take the polynomial. Let p of x as nothing but is equal to 3x square minus of x cube minus of 3x plus of 5. Let's just arrange it. So we can write it as p of x is equal to the highest degree of the variable x over here is nothing but minus of x cube plus then we have 3x square, then we have 3x, and then we have 5. So we have arranged p of x polynomial in the descending order of their degrees. Now let's just talk about the other polynomial. So let us suppose I'm taking it as g of x. And let us suppose I am arranging this particular polynomial in the descending order of their degree. So we can write it as minus of x of square plus of x minus of 1. Now we have the two polynomials p of x and g of x. Now let's just divide these two polynomials all together. So let us suppose we are using the division process, and we have minus of x square plus of x minus of 1 as nothing but our divisor, and we have the dividend as minus of x of cube plus of 3x square minus of 3 of x plus of 5. Now let's just divide both of these. First of all, we have to divide the first term of the dividend and the first term of the divisor. So minus x cube divided by minus of x square, when you will divide, you will definitely get the first term as nothing but x. So it means we have the first term of our quotient as nothing but x. So minus of x square into of x, let's just multiply both of these terms all together. So it will be x into minus x square as nothing but minus of x cube. Then further plus x plus of x, so we have plus of x square minus 1 into x as nothing but minus of x. Now let's just change the signs of all these terms, because as we are subtracting, so the new signs for minus of x cube is nothing but positive. Again it is negative, again it is positive. Now these terms get cancelled with each other. Again plus 3x square minus x square is nothing but plus of 2 of x square. Further we have minus 3x plus x as nothing but minus of 2 of x. Again we have plus 5 as a constant, so let's just take this plus 5 as it is over here. Now again we have 2x square, we have minus of x square. Obviously both of these degrees are equal to each other, so we have to repeat the process, division process again. So let's just divide 2x square with minus x square. We will get the term as minus of 2. So minus of 2 will get multiplied with all these terms again. So it will be minus minus plus, so it is plus 2x square minus 2 plus x is minus of 2 of x. Further minus 2 into minus of 1 is nothing but plus of 2. Okay, now let's just take the signs as we are subtracting these two terms. So it will be negative, it will be positive, it will be negative. Again, both of these terms will get cancelled with each other. Again, we have minus 2x plus 2x. Again, both of these terms are cancelled with each other. Further, we have plus 5 minus 2. We will get the answer as nothing but 3. It means that the remainder is now 3, and it definitely do have the degree less than the degree of the divisor which is given to us. So hence at the end, how we can represent it? We can represent it in a very special manner. So let us suppose I am calling this x minus 2 into the formation of q of x. Let us suppose I am taking it as q of x, and I am taking it as nothing but r of x. I am taking it as r of x. So let us suppose we are taking the right hand side or the left hand side of the division algorithm. We do know that the division algorithm says, P of x can be represented as g of x into q of x plus of r of x. Division algorithm says Px can be represented as Gx into Qx plus R of x. So let us suppose, as we have to verify the algorithm, we are taking the right hand side. We are taking the right hand side of the division algorithm only. That is Gx, Qx plus R of x. So let us suppose I am taking the right hand side of the division algorithm only. So it is G of x, Q of x plus R of x. So let's just take all these terms. G of x, as we know, we have G of x as nothing but minus of x square plus of x minus of 1. The quotient q of x is nothing but x minus of 2 over here plus remainder. What is the remainder? The remainder that we are getting at the end is nothing but 3. So let's just multiply all these terms all together, and if we will get the answer as nothing but is equal to p of x, hence the division algorithm verifies, else the division algorithm doesn't verify. So let's just start multiplying all these terms together. So we will have, let us suppose we are multiplying these two terms. So let us suppose we are taking x outside and we are multiplying it with minus x square plus of x minus of 1, minus of 2, minus of x square plus of x minus of 1 and plus 3 as it is. Now let's just multiply all these terms. So this is minus of x cube plus of x square minus of x minus minus is plus 2x square minus of 2x, minus 2 minus 1 is plus of 2 plus of 3. Now let's just add up all the like terms all together. So it is minus of x cube. X square plus 2x square is nothing but plus of 3x square. Further, minus x minus 2x is nothing but minus of 3 of x plus of 3 plus 2 is nothing but 5. So hence at the end what we are getting the answer as minus x cube plus 3x square minus of 3x plus of 5, and definitely this is nothing but is equal to the px polynomial that we do have. Px is minus x cube plus 3x square minus 3x plus of 5. So hence it implies it is nothing but is equal to LHS. So at the end what we have verified? We have verified that the polynomial p of x can be represented as g of x into q of x plus of r of x. So hence the division algorithm actually verified. Hence the division algorithm verified. So this is all about the division algorithm for any particular two polynomials px and gx.